Okay, it is actually flow diagram. Right, so you can, let me just see. Okay, so you have flow diagram, process chart. Okay, I'm going to just go through this and activity charts, operation state charts. So these are the tools that you can use to analyze jobs. So what are their main differences? Can you think about what are their main differences and relate back to their focus areas? Okay. Why are they different? Why do you think that they will need to create different types of charts to analyze jobs? So what are their main differences? If I want to analyze movement of individuals, which chart can I use? Yuki, which chart can I use? Which chart should I use if I want to analyze the movement of individuals and materials?
I think process charts maybe.
Process charts. Do you agree, Yule? Anyone agree? Yes. Anyone who agree? Yes. Okay. So other than process charts, you can also use flow diagrams. Okay. So if you look at this, of course, there are many other charts actually. There are many other charts because this is only basic methods analysis. Okay. If you study engineering, then probably you have more other charts. So anyway, let's see. Okay. So you have flow diagram, process chart, activity chart, and it depends on the focus, right? So I'm going to give you a quiz now. Now, I've given you the answer already just now. So what's the flow diagram and process chart is used for analyzing A, B, C, D? Type in the chat box. Okay, type in the chat box. Okay, you can copy your friend. Okay, you can think for yourself. Just type in the answer A or B or C or D. All of you, just type in the chat box. Okay. The question is, flow diagram and process chart is used for analyzing material flow, worker flow, A, B, human and machine activities, C, body movement, D, action movement. Okay, I got one answer already, so I need another 4 more answers. You know, in Zoom, there is chat box, so you can just type the, it's A, B, C, or D. Just type your answer. Then we can see. Or you can answer. Do you see the question in the poll box? Is there a poll? Yeah, just click anyone and just, put in your answer. So I see one response. Two response. Three response. That's very interesting. Okay. So two more. Please key in your answer. One more. Who have not answered yet in the poll? Because there's 5 of you, I only have 4 answers, 4 response. So who has not answered yet? Who has not responded to the poll? Who have you answered? You, Hong?
Yes, I've answered the questions. I
Put the poll in the poll. Who has not answered in the poll?
yes, I did.
Okay. Yuki, have you put in the poll?
I think I
Because
want
there's
to
only
think.
4. There's only 4 response. One of you answered A. 2 of you answered B. One of you answered D. Okay. There's only 4 of you answered. What's the correct answer? What's the correct answer? Okay, I give you another chance. But this time you just tell me, you can change your answer if you feel that your answer is not right. Anyone want to change the answer? Please read again. Okay, please read again. Okay, let me just, probably you need to see this. Okay. There are 3 main areas to analyze. One is movement of individuals or material. So when we say movement, it's actually flow. Okay, flow. Activities of human is, the interaction between human and machine. And the third is body movement. Okay. And it is related to these 4 charts, right? Flow diagram, process chart, activity. So if you see here, what is this figure 10.5 flow diagram? The arrow, what is it showing? Can anyone tell me what the flow, the arrow is showing? Yule, what is the arrow showing here? There are arrows here. Okay, a flow diagram shows, what is this arrow showing? Think about it.
Material flow, maybe?
Exactly, material flow, because this is material flow. So, and also individual doing the work here needs to move. So this is showing the movement of workers or individuals. If you look at this, this is flow diagram. The second diagram here is flow process chart. Operations, transport, inspect, delay, and storage are the activities, okay? And it's also, it's not showing human and machine activities. It is showing the flow of material as well as workflow, basically. So the answer is actually A. Okay, the answer is A. Material flow and workflow. Okay. Can you understand? Can you understand now? Okay. I think you will remember this for the rest of your life. Surely. Surely you will remember this for the rest of your life, because I've already explained to you. Flow, flow, okay, flow. Now, any questions? Any questions? Okay, good. So the next one. Operations chart is used for analyzing. So this is an operations chart. Operations chart shows right hand and left hand. Right hand movement, reach for cup. Left hand, and then right hand is idle. Idle means doesn't do any activity. Okay. So if you okay, no need this. Let me just. Okay. So think about it. I just want you to see question 2. Okay, I found it. So again, please click your answer.
I want to ask a question.
Yes, yes.
What's the difference? Between body movement and action movement?
Body movement is the parts of the, for example, the hands, the what do you call? It is actually body movement.
Yes.
Action movement is the activity. Okay, the activity itself. It got no meaning actually. Action movement is nothing. It's just made up. Okay.
Okay.
It's made up for you to get confused. Okay. There's no such thing as action movement. Okay. Please, well, the answers are actually in the book. Okay, if you look at the book, you can actually immediately see the answer. Right. So 3 of you have answered. So I wait for another 2 person. Are all of you having a computer in front of you? Yes. So I've launched the poll. The poll is there. You should be able to 4 out of 5 actually answered. Oh, okay, all of you have answered. Okay. So the answer is most of you got it right. Okay, most of you 60%. Okay. So you want to think about it, right? who chose human and machine activity? Can you give me a reason why you choose human and machine activity?
Me?
Who chose B? Who
I
actually gave B?
I gave C.
You gave C. Okay.
Yes.
Who gave B? Probably want to have an explanation why you give B as the answer. I don't know who actually answered B. If you can identify, and who actually gave B as an answer. So what's the answer actually? Yu Hong, what's the answer?
I choose C
Why you choose C?
because I read the
You read the book, okay. The book says operations chart is actually a body movement, exactly. So it's actually operations body movement. Because when you say body movement, it's actually the hands, okay, left hand activity, right hand activity. So it is reaching for the cup, it is grasping the cup, it's moving the cup, it's holding the cup. Reach for scoop, scoop ice to coffee cup. So this is right hand, left hand chart, okay. So I have not shown you the, so the other chart is actually this chart, okay. The other chart is this chart. So I've shown you, asked you to actually analyze these two charts. This is the activity man-machine, human interaction with machine. Because when you, there's a difference between operation chart, because operation chart is just showing the body movement, okay, hands especially. But for the activity chart, there is machine, there is an equipment that you work with, okay. So this is actually activity chart, which is actually used for activity of human and machine, the second type of chart, the third type of the technique, okay. So the other one are the same. This is process chart, flow diagram, which is actually analyzing the human activity flow, human flow, not human activity, human flow, okay, and material flow. Okay, right. Questions? Any questions? That's why I encourage you to actually view my, I'm not going to lecture, okay? You have to view my video that I have already lectured, and I've given the, you know, the things, for example, the visual workplace and so on. Okay, the next thing I'm going to talk about is actually labor standards. Okay, labor standards. So we want to define labor standards, and what constitute a fair day's work. If you work 8 hours a day, 8 hours a day, okay, so preparing a report, how long should you take? You know, doing some calculation or manipulation of data, how long does it take? So this is what we mean by labor standard, setting the amount of work that is suitable for your level, for your what do you call job scope, for example, okay. And also the uses of labor standards, especially when you look at manual operations, okay, because so right until now, a lot of our economy is actually based on manual operations, manual work, okay. So what is labor standards? What is labor standard? Okay, Ho, can you read this? Can you read what I've written here? Yeah.
present amount of time that it should take an average employee to perform specific job activities under normal working conditions.
Under normal working conditions. So labor standards means the amount of time that an average employee. So it is not about, asking an employee who actually work very fast to do the to become the standard. Because if you set the standard based on the worker who can do fast, then he's going to affect the rest of the other worker. For example, you do assembly of tires, assemble tires, or you fix, you cut cotton, or not cotton, you cut the cloth. Okay, when you want to do sewing, you cut. So cutting is a process. So how long does it take? So that is what we want to establish. Okay, not only that, but any other job that is being done by human. Okay, human. So what is the purpose of labor standards? What's the purpose of labor standards? What does it provide to a company? Can you think of one specific purpose that a company will benefit by having, if I want to do the job, okay, I need the time. So what's the purpose? Anyone? If you are a manager of a company, I need to know the time. What benefit does it give to you? So that's the purpose, okay? What benefit does it give to you? Anyone?
Well,
Yeah,
maybe help the company to now or determine the cost of
exactly,
the
okay. Cost
product.
of product, okay. In what? Why you say product?
Well, in the streamline, it's just create a product by the labor.
Yeah, okay. So labor cost, basically labor cost, because labor cost goes into the product. Okay. So you can determine labor cost. What else? If I know the time to do, if I have the product requires, many steps, many workers. If I know the time, what else can I use the time for? What can I use the time for? Yu Hong.
I think it can protect workers' health.
Protect
Workers'
health.
Mm.
Okay. In what way? How does it protect the workers' health?
If workers work for too long time, they were
Okay.
get sick.
So you are trying to optimize the working time, basically. Okay, so that the worker is not being too much work and also stress. Okay, good one. Anyone else?
How about allocate the payment for workers, like the standards, which worker just work overtime and pay him for the extra pay.
So labor standards are used to determine wages, or even they call it incentive schemes. Okay, incentive scheme in terms of some kind of job. For example, making clothes. So you worker a standard time is, for example, you can do the sewing for the collar, 2 minutes. So if the worker is fast, he can get incentive, bonus, extra. Okay, so that's is why you need standards. Okay. Allocate payment. What else? There's a lot of things. Okay, a lot of things. What about determining the number of workers? Do you need the time to determine the number of workers needed? Aho? If you do not know the time required, can you determine the number of workers to do the job?
Yes.
So you need time, right? You need the time for each work, then only you can actually determine the number of workers needed in the production line. The production line has, you need to install tires, you need to install brakes. So this is the length of the production line. And there are 2 workers for each station. So how many stations do you need? You need the time. Then only you can determine the number of workers. Okay. Yes, Ho, you're thinking, you're trying to say something. What else? What else? So if you look at there is so many, the books also give you a lot of these standards for what do you call the purpose. Okay, so the book gives this labor contents, of items produced, staffing needs, which I said just now, cost and time estimates, crew size, work balance, and balancing the work. Expected production. If you do not know the number of employees, you don't know how many can be produced. Number 5, item number 5, expected production. Number 6, that's what we said just now, basis of which incentive plans. That means the extra bonus or the extra piece rate, and they call it piece rate. Piece rate, that means after the standard volume, for example, you work 8 hours, the worker can make 100 trousers or shirts, 100 shirts. After another one, okay, he'll be paid 50 cents for bonus. Additional quantity, that is wage incentive plans. And of course, efficiency of employees, you can determine the employees, efficiency. So very useful, very important labor standards. It is important that all jobs have labor standards, okay? In Japan, they clean the Shinkansen, right? Whenever Shinkansen comes. Have you seen the video of the cleaner go into the Shinkansen, and within, I don't know, less than 5 minutes, it's already clean, they will go out, okay? So, but they work very fast, very fast. Go and find the video of, labor standards for cleaning of Shinkansen. They arrive and they clean up the what do you call the train. Okay. What are the 4 ways of setting labor standards? There are many ways of setting labor standards. Setting means determining. Okay. So now we know the importance of labor standards. So I need to determine. I want to set. So what are the 4 ways of setting labor standards? What are the book gives, what are the standards?
Their historical experience and time
experience, time study,
predetermined time standards, and work sampling.
Okay, I just type it here. Okay, historical experience, time study, okay. Is it predetermined time standard? The book gives this.
Predetermined.
Time standards.
Okay, predetermined. Okay. So we're going to look at some of these. Determine. And finally,
Work sampling.
work sampling. Okay. So we're going to go through this. Okay. These so-called standards, right? If you look at the definition, if you look at the word itself, for example, number 1, historical experience. So what does it means when you say historical experience? Historical. Fangi, what is historical experience?
Like the other workers, like for example, like the example the professor have given about the Shinkansen cleaning, here is a worker like use the most fast time to clean the Shinkansen.
That is established by, I know, that is using number 2, time study. It will
about
not.
maybe about the other companies' experience about the history data.
So it's not scientific. Basically, when you talk about historical experience, it is non-scientific, non-engineering, non-scientific. It is just based on your own gut feelings, historical experience. So I have been doing this work, and it takes me to clear the garden 1 hour. So that's my experience. Okay, so it's historical. Historical means it's your past experience. So it's not scientific. Whereas the 3, okay, time study, predetermined, time standard, and work sampling are scientific, and also it is very structured. When I say structured, it means there's a way of how actually it's being done. Okay. Right. So time study is a method in which it is being done by trained and experienced person, establish the standard time using 8 steps. So basically, this is done by a trained person. Okay, but for your purpose, I think it's just for you to have an idea. I'm not, you don't have to become expert in time study. I'm not asking you. I'm just trying to, make you aware of this method. There is a method. Okay, there is a method which can establish standard time. So this, when we do time study, this is the new thing that you need to understand. 4 things. 1 is average observed time, which is the mean time of work elements. When you say work elements, it is the tasks that you do and you break down into smaller elements. And then there is a performance rating. Why you need performance rating? Because you want to adjust to a trained worker capability. And also, we are going to calculate the normal time. So you're going to have an observed time, which is raw data. Observed time is raw data. And you calculate normal time and standard time. And the standard time, you need to adjust for allowances. Allowances mean something that you will see after this. Okay, allowances is something that you add to the time, because not everyone can do the work as fast as you do the observation. Okay, when you do observation, you are taking data from a person doing the job. The problem with time study is that you have to have the job, then only you can take the time. Okay, if you cannot It's not pre-planned. It cannot be pre-planned. Okay. Right. So this is the 8 steps. Okay, 8 steps. It is actually I've taken this from the book because I want to show it in one slide. Okay, 8 steps. Number 1 is to define the task to be studied. After method analysis has been conducted, that means you have document the process, the flow and everything. So you want to define the task to be studied. And you want to divide the task. So the word is divide. What do you mean divide? What do you mean by divide the task? Number 2, divide the task into precise elements. That means part of the task that become, you can take the time actually, that often take no more than a few seconds. If it is too small, if it's 1 second, then you cannot take the time. It is, you need to have like 2 seconds or 5 seconds duration. Okay, then you can actually take the time. Number 3, decide how many times to measure the task. That means the job cycles, the samples needed. Why you need to take the samples needed? Because you want to ensure accuracy. In scientific study, you need to have accuracy. So you need to calculate the sample, sufficient sample size. Then this is the planning. 1, 2, 3, define, divide the task, decide how many times. Then only you start the actual time and recording of the elemental times. Okay, so time, and you have to time. That means you have to have a stopwatch, or you have to have your, watch that you can measure time. Okay, so number 4 is time and record the elemental time. Ratings. Here you introduce rating. That's why it is done by someone who is trained. When we say rating, we are actually giving our judgment. That means if I analyze the work, I say this worker is working at 100% speed, okay, or 120% speed. There are ways of determining that. Okay, there are ways. So you compute the having number 4, so you need a table actually. You need a table to record that. And then number 5 is compute the average observed time. So the first thing that you calculate is average observed time, which is the mean of the time for each element measured. Something that you need to be aware is adjusted for unusual influence for each element. That means the work, if there is something which is not normal, then you need to remove that from the data, because if you put in the data, it will produce error, basically wrong reading or wrong calculation. So here it is, average observed time is the sum of times recorded to perform each element divided by the number of observations. Then you determine the performance rating. Number 6, performance rating, and compute the normal time using this formula. Okay, normal time is average observed time times performance rating factor. And I mentioned just now, right? The performance rating adjusts the average observed time to which a trained worker could expect to accomplish working at a normal pace. For example, a worker should be able to walk 3 miles per hour. Normal human being walk 3 miles per hour. So, or he or she should be able to deal a deck of 52 cards into 4 equal piles in 30 seconds. That's normal human being speed. Okay. So if he walk faster than, your movement should be normal. Okay. If you work fast, then you should give rating. So a performance rating of 1.05 means that the task is slightly faster than average. So you give that 0.05 additional. If it's the same, then you don't give any rating. It's just 1.00. So you can see videos, specify workspace, and there are benchmarks on that. Performance rating is still somewhat an art. Why is it an art? Because it is judgment. Because it is based on the observer eyes. For example, if I do work, I've seen welding work, so I know how fast the worker is actually doing. And you add the normal times. Number 7, you add the normal times to develop a total normal time for the task. And finally, you compute the standard time. So the adjustment to the total time, this is where you put in allowance. Okay, we'll go to the example, then you can see this. I know for sure I cannot just give you and ask you to do it, because you need to understand this basic first. Personal needs, worker unavoidable work delays, worker fatigue. Okay, so we need to give them allowance. Why? If the work, for example, works, it's a very hot environment, and you don't give that allowance of additional 10% of the time, so he won't be able to recover and he will just fatigue, right? So that's why we give the allowance. So that's why I said just now, this is important when we set standard time, adjust the normal time to include allowances, fatigue, personal fatigue, delay allowances. Okay. So this is the, there is a lot of, there's various tables, but this is just one example. Okay, just one example. Allowance factors for various classes of work. Personal allowances 5%, basic 4%, and so on. Okay. Weights, bad lighting, noise level, and so on. So I'm going to go through example 2 briefly. If you have any questions, please stop me. Okay. Now this is the data that is being taken. Okay, a standard study has been conducted on the task of preparing letters for mail. So it has been broken down into 3 job elements, A, B, C. Okay, and the observations 5 times, 5 cycles. So for the first cycle, so the job is completed in 8, 9, 10, 11, 12, okay, whatever it is, probably 12 minutes. And probably it's not just one letter, it's probably a few letters. So 10 minutes here. The second cycle is 10, 13, 14 minutes. So this is the cycle, right? Cycle, cycle, cycle. And this is the time for each element, 8, 10, 9, 21. If you remember this now, any abnormal, okay, if you see the asterisk here, delete observations such as those with asterisks, because 8, 10, 9, 21 is abnormal from all these other readings. Okay, so that's why it's being removed, because you don't want to take the average time based on an abnormal data. Okay, so you want to remove that. Okay. So that's what it says here, delete observation. So that's the first one, number 1, compute average time, compute normal time, find the total normal time, compute the standard time. Okay, so the average time for A is 945 minutes, eliminating 21. So you only have 4 data, 1, 2, 3, 4. Average time for B is also, but this is taken, 5 data is taken, 2.2 minutes. Average time for C also removed the one which is actually abnormal, which is 5 here, because the rest is just 1 and 2. So you eliminate that, you delete that. And normal time is average observed time, time performance rating. In this case, the performance rating is given here. You see if you notice here, performance rating is 120% for element A, 105% for element B, 110% for element C. Okay, so different performance rating. That means the worker is doing faster than what an average worker would able to do. So by doing that, so you have this normal time, 9.5 times 1.2. Normal time for B is 2.2 times 1.05 and so on. Okay. So you add the normal time. Step 4 is add the normal time to find the total normal time, which is 15.36 minutes. And number 5 is total normal time. Any questions until now? Any questions? Can you follow? Can you follow the steps? Okay. And finally, then only you put in, you calculate your standard time, which is total normal time divided by 1 minus allowance factor. It says somewhere that the allowance factor or the allowance is 15%. So it's 0.15 here. Okay, 0.15. So it is 15%. And finally, you will get 18 minutes. So this, for this job, the standard time given is 18 minutes to actually do the, complete the job. Okay. Right. Okay. So that is the general step. Okay, that is the normal general step of time study. Okay. But the most difficult thing is actually to take the time, actually. Take the time. Taking the time is the most, not most difficult. It's one of the difficult thing, and also breaking the job elements. Okay, breaking down into job elements is also another task. Okay, I need to also describe to you about sampling process. Okay, because time study, there is the question of sampling error. So the average observed time, there are errors involved. If we take too little data, too little cycles, then it will actually result into some accuracy issues. So in statistics, error varies inversely with sample size. So we want to know how many cycles we should time. So we must consider variability. And to determine adequate sample size, you must consider 3 things. First, how accurate we want to. For example, we want to be within 5% of observed time. So is it enough? 5% error, so plus minus 5%, we say that, okay? Of course, 1% is going to be much more, detailed, okay? And the desired level of confidence, for example, 90%, is it enough or not? Or 99, 95%. So it's just using a formula statistically. So the required sample size N is ZS divided by H X bar to the power squared, okay, H squared. So H the accuracy level, Z is the number of standard deviation required. That means in terms of confidence level, okay, confidence level. And standard deviation of the initial sample is S, mean of the initial sample, X bar, and N is the required sample size. So N is the unknown. Let me see whether there is an example. Okay. So the book gives an example of this. So you want to check the level standard prepared by someone, okay, some analyst. So you want to know the correct sample size. If the company decide that your accuracy level is plus minus 5% and your confidence level is 95%, okay, statistically. So the standard deviation, given that the standard deviation, this is from the sample, okay? Sample standard deviation is 1 and the mean is 3. So what you need to do is just put into the formula all these values, okay? So H is 0.05, this is H, X bar is 3, S is 1, and you talk about 95% confidence. So 95% confident interval is looking at this table here. So this is the common Z value. So 95% will give you a Z value of 1.96. So you put inside here Z. Okay, Z is the number of standard deviation required based on your confidence interval, 95%. So it's 1.96 in this case. So 1.96 times 1 divided by 0.05 times 3 squared. So you need 171 samples. Okay, so you need to take 171. If you have taken 10, you need to take another 161. Total. So whatever you have taken is already considered data. So if you have taken 5, so you need to take another 166. Okay, so that's total, the total number of samples that is required. Okay. It's 11 o'clock. Okay, time is very fast. You can take your break, but you can take your break while solving this problem. Okay, so I'm giving you 10 minutes to solve this problem. I'm going to break you into 2 groups, and you can give me, share the answer after let's say 15 minutes, 11:10. Okay, 11:10. I'm going to actually call you back into the. I'm going to split you into breakout rooms. Okay. So group 1, I'm just randomly putting you according to the list. Okay. So okay, 2 and 3. So good luck. Okay, I will assign you to your rooms. Please join the room, and I'll see you back at 11:10. You cannot join the group, Fang Yi. You need to do 1026, okay? Problem 10.26.
Yeah.
Yes.
You know, okay.
去问问他。
没关系。
Oh, hello, Professor. I want to know which question. I forgot the question number. The number of the question. You are muting. You are muting.
Oh, sorry, 10.25.
10.25. We do 10.25, right?
Yeah. Okay, 10.25. Okay.
Okay.
Right.